Hi, hello sir. I'm Sarvesh Rao, and today I will be discussing regarding our Lab 2, Section B. Alright, so first and foremost, let's look at the full connection circuit from the video that we did during our time in lab. So, firstly, we have our power cables. So, from our power cables, we have two phase that will be supplied to the secondary transformer, and we must ensure we install grounding throughout the circuit to ensure protection. So this will be our connecting rod, and from connecting rod we have our connection cup and we have our electrodes to avoid the effects of corona effects. And we have our grounding switch and we have our measuring capacitor. So from here you can see from our measuring capacitor 100 picofarad we have coaxial cable with a length of 40 centimeter and with the impedance of 50 ohms that will be connected to our input of secondary capacitor through banana BNC to banana plug adapter. Okay, so additionally we must install grounding as well to ensure protection for our secondary capacitor. So from the output of the secondary capacitor we also have our BNC to banana plug adapter, and immediately it's contacted with BNC T junction, and the connection will be split into two, and we can send two signal, and one is to the frequency cabinet which indicate VM1 for AC measurement purpose, and another left side, let's say this is the right side, that's the left side will be to frequency cabinet, and the right side will be to our picoscope 4000 series. So this is the left side, which will be connected to our frequency cabinet VM1, which will, and we will have two readings from that, V peak and V peak over square root 2, oh sorry, VRMS and V peak square root 2. So there will be two values, and this will be the cable. Right side of the um, cable is will send signal to our picoscope 4000. All right, so okay, not this. All right, and these are the questions that we need to answer in our lab sheet. Okay, this is the equivalent circuit we draw. This is the primary side and this is the secondary side. And since if we intended to inject, we intended to generate 100 kilovolt at the secondary side, we must inject 440 volt at the primary side. So how do we measure our voltage readings during the injection times? So obviously we cannot read 100 kilowatt traditionally like we do for 240 volt by using voltmeter, because it's extremely dangerous. So we have to reduce it to a low level of voltage for our measurement purposes and for safety purposes. All right, so for that we have our 2 microfarad secondary capacitor. We will connect our um, we will connect from the 100 picofarad to the secondary capacitor through a coaxial cable for measurement purposes. And this is basically the equivalent circuit diagrams that we draw, that our team draw, to just to represent in terms of diagram what is it about the connections. Okay, so this will be for the 100 picofarad measuring capacitor, and we will have our coaxial cable connected to it, and to BNC to banana plug to our secondary capacitor, and we must ensure we install uh, grounding wires as well to ensure protections. And from output of the secondary capacitor we have our BNC to banana plug, and we'll immediately contact with our BNC T junctions, and it will send two signal, basically same signal. We can have send two signal, and is to the frequency cabinet key control, another one is to our picoscope. And yeah, this is what a coaxial cable looks like. It's just a question that we answered, and this is our suggestion regarding our safety rules action that needs to be concerned at the earthing switch and the clean testing layouts. And this is basically the equivalent diagram for full connections for our construction of our high voltage generation and measuring circuit. So this is the answer for puzzle layout question that we did. So that's it from me, sir. Thank you.